Hello, everyone. I just wanted to make a video to help you with transforming exponential functions. We weren't able to get to the transformations in class, so I'm going to go through that with you now. So we were able to graph our basic exponential functions. So we did this one in class. Y equals 2 to the x is an increasing exponential function from left to right. This is exponential growth. And it has a horizontal asymptote at y equals 0. And y equals 1/2 to the x looks like this. It is a decreasing exponential function from left to right. We call that exponential decay. And again, this one has a horizontal asymptote at y equals 0. Okay, so these are what our basic exponential graphs look like. If our base is bigger than 1, we're going to be increasing like 2 to the x. If our base is a fraction between 0 and 1, we're going to be decreasing left to right here like 1/2 to the x. Now, the transformations that we're going to see of these guys look like this. So we might have a negative out front. So this plus or minus here means that it could be positive or it could be negative out here. If it's negative, we're going to have a transformation. And we might also be adding or subtracting a number up here in the exponent with x. And that is adding or subtracting inside our exponential function with x. So we're going to lean on some of our previous programming for that. And we might add or subtract a number out here on the outside. Okay, so let's talk about what each of these is going to do. So let's first start with this plus or minus out front. If there is a negative out front, then we are multiplying by a negative on the outside of our function. If we recall what we learned previously from transforming graphs, if you multiply by a negative on the outside of our function, we're going to get a reflection. And because it's on the outside, we are going to, it's going to be a vertical reflection, right? We're going to reflect this up or down over the x-axis. This is going to stay consistent with our previous programming from transformations of graphs. And then if we have a positive outside, we're really not going to do anything with that. If it's a plus out there, we're not even going to write the plus. You won't have to worry about it. So really, you just need to worry about if there's a minus out there. I just wrote plus or minus here because sometimes you'll have a negative and sometimes you won't. All right, and then let's move up to this exponent. We might add or subtract an h up there with x. If you add or subtract a number inside your function with x, because it's inside, that's going to move us left and right. And when we have something on the inside, it's going to do the opposite of what we think it will. So if we have a minus h up there with x, if it is x minus h, that is going to shift our graph to the right by h units. And again, this should be consistent with what we did before. If we add a number h inside with x, then that is going to shift our graph to the left by h units. Again, it does the opposite of what you think it will, and it is inside, so it's going to be a horizontal change. And then the last one here is if we add or subtract a number outside here, because we are adding or subtracting outside, that's going to be a vertical shift, and this is going to go the way that you think it will. So if you have a plus k out there, you're going to shift your graph up k units. And if you have a minus k out there, you're going to shift your graph down by k units. just the way that you think it's going to work, and that's going to stay consistent with all of our programming from before. Um, One thing that I want to make note of here, we have a horizontal asymptote with our exponential functions. And so when we move our graph around, sometimes that's going to affect our horizontal asymptote along with the rest of the graph. Now, if we reflect our graph up and down over the x-axis, that's actually not going to affect our asymptote, our horizontal asymptote. It's going to stay right where it is on the x-axis. If we shift our graph right or left, that's also not going to affect our horizontal asymptote. It's going to stay in the same place and just kind of shift left and right in the same place. But if we move our graph up and down, the vertical asymptote is going to move with it. So I just want you to note that the horizontal asymptote will move up or down with your graph. Again, this is the only change that's going to move it. It's going to be when you shift it up or down. That's what's going to move your horizontal asymptote. And we'll talk about that in a little bit with an example. And then I just want to remind you and have you recall here that the order in which we do these transformation does matter. We would get different graphs with different orders, so we got to make sure that we do these in the right order. So the first thing that I need you to do here is do your horizontal shifting. So you will shift left and right first. That's right, based on these guys, that plus or minus h up there with x. The second thing that you're going to do are your reflections, which depends on this plus or minus out here out front. If you have a negative out there, go ahead and reflect it. And then the very last thing that you are going to do is shift your graph up and down. So that's this guy right here. That's the third thing that you're going to do in order. So order does matter, and we're going to be careful with that. Okay, so let's try these. I've got some examples here. I just want to list the transformations that we have and the order in which we would perform them. Now, notice in all of these graphs and all of these examples, the base of my exponential function is 3, right? This is a 3 to the x. I know I've got a plus 2 up there with x. That's going to give us a transformation, but I've got 3 to my variable x. Here I've got 3 to my variable x. Here I've got 3 to my variable x. And here I've got 3 to my variable x. Notice that the base of all of these is 3. And what that means is that the base graph for all of these, the ones that I would start with, is y equals 3 to the x power. Because my base is bigger than 1, this is going to be exponential growth. We're going to be increasing from left to right. And if we wanted to, we could pick a couple points, right? If x was 0, then y would be 3 to the 0, which is 1. If x was 1, y would be 3 to the first power, which is 3. And if x was negative 1, y would be 3 to the negative 1 power, which is 1/3. So my base graph is going to look something like this. I know that's not perfect. I'm sorry that that's not super perfect. You can use your imagination there, but that's roughly what the base of this is going to look like. And then each of these extra things here is going to cause a transformation. So let's start to identify what transformations that we would have. So in number 1, I've got 3 to the x plus 2 power. So the transformation here from the original is this plus 2 up here with the x. Because it is up here inside the exponential with x, this is going to be a horizontal shift. It's going to move us left and right, and it's going to go the opposite way you think it will. So this is going to move us to the left 2 units. This says list the transformations in the order that we would perform them. This is the only transformation that we have. So I'm just going to list this one. We would move it to the left by 2 units. Okay. And I just want to kind of make note here. Um, this base function has a horizontal asymptote at y equals 0. If I shift this whole thing left and right, and my horizontal asymptote moves left and right, it's actually not moving at all. It's going to stay in the same place. So with number 1 here, our horizontal asymptote's not going anywhere. Number 2, g of x equals 3 to the x plus 2. This time, instead of adding the 2 up in the exponent with x, I'm adding it down here on the outside of my exponential. Because I'm adding it to the outside, this thing's going to move us up and down. Outside moves the way you think it will, so that's going to move us up 2 units. And that's the only transformation that I have here, so the only thing I'm going to do is shift the graph up 2 units. Now, notice when I do that, I just want to make a quick note here. Imagine shifting this whole y equals 3 to the x graph up by 2 units. When I do that, this horizontal asymptote is also going to move up 2 units with the graph. So the horizontal asymptote also goes up 2 units. And when I do that, it's going to shift to y equals 2. That's where my horizontal asymptote will go. Okay. The next one here, number 3. Now I've got some more things going on here. I've got a negative out front here, and I've got a -1 out here. This negative out front here with a 3 to the x, because I am multiplying by a negative on the outside, this is going to give us a reflection. And this -1 out here on the outside, because I'm subtracting on the outside, this is going to shift us down 1 unit. So those are my transformations. Now the question is, what order would we do these in? So the first thing we're going to do is shift left and right, but we don't have any left and right shifting, so we won't worry about that. And then the next thing that we'll do, which here is going to be the first transformation we have, is we'll do any reflections. So here we're going to reflect up and down over the x-axis because of that negative. And then the last thing that we're going to do is our vertical shifting, which here we are going to move our graph down 1 unit. So those are my transformations in the order that we would perform them. And because we're moving this graph down 1, when we slide this whole thing down, my horizontal asymptote is going to move with it. So my horizontal asymptote also moves down 1 unit, which means it's going to be at y equals -1 at the end of all of this. Okay, and then number 4. K of x equals 2 minus 3 to the x. Now, if I keep it in its current form, this can be kind of difficult for our brain to uh, kind of sift through. So I'm going to rewrite this and put my exponential function first and any addition or subtraction to the end. So this negative is attached to that 3 to the x. It's attached out front. So I'm going to write that first. I'm going to have -3 to the x. Oops. And this 2 is being added, right? It's a +2. So I'm going to put that over here. This is the same as -3 to the x plus 2. Our brains are going to process this a little bit better than in the original format. So when we write it this way, you can see this negative out front. That's going to give us a reflection. And this +2 here, because I'm adding 2 on the outside, that's going to shift us up 2 units. And then the order we're going to do this, first one, we'll do the reflection first. And again, that's a vertical reflection over the x-axis. And then the last thing that we're going to do is move this whole thing up 2. And those are our transformations. Does our horizontal asymptote move at all? Well, because we moved up 2, our horizontal asymptote will move up with our graph. So I'm just going to make a note that our horizontal asymptote always also moves up 2, and it ends at y equals 2 after we add that 2 up there. All right, and that is identifying these transformations and the order that they would be performed. We're not asked to identify the horizontal asymptote shifting. I just wanted to include that just so we don't forget, and it can really help with the graphing. All right, so the last one that we're going to do here with the exponential transformations is actually perform one of these things. I want to graph m of x equals negative 3 to the x plus 4 minus 2. Okay, so I'm going to first figure out what my base function would be. So to figure out what our base function would be, we are going to kind of cover up all of the things that would cause transformations. So I'm going to kind of get rid of everything here that would cause a transformation. And what I'm left with is 3 to the x. So my base function is y equals 3 to the x. So I'm just going to make a note that my base graph is y equals 3 to the x power. And I'll go ahead and graph that while I'm here. If x equals 0, then y is 3 to the 0 power, which is 1, because anything to the 0 power is 1. If x equals 1, then y equals 3 to the first power, which is 3. If x equals -1, y equals 3 to the -1 power, which is 1 over 3 to the first, which is 1/3. So I'll just eyeball that. So this is what my base exponential graph looks like. And we have a horizontal asymptote here at y equals 0 to start out with. Okay. All right, so now let's see about transformations. So I've got a negative out front. That's going to reflect us. I've got a plus 4 up here in the exponent with x. That's inside my exponential function. So this is going to move us to the left by 4 units. Again, that's going to go the opposite way that you think it will. And this -2 out here is going to go the way you think it will. It's moving us up and down because it's on the outside. So this is going to move us down 2 units. So now which order will we do all of this in? I'm going to pick a couple of colors here to try to keep track of all of this. The first thing that we're going to do is slide left and right. So we're going to have to go left 4, the first thing that we'll do. And then after we go to the left 4 units, the second thing that we'll do is do any reflections that we have. And in this case, we will need to reflect up and down over the x-axis. And the last thing that we'll do is the moving this down 2 units. And when we move the whole thing down, the horizontal asymptote will move with it. Okay. So let's start making these changes. The first thing that we're going to do is shift this whole thing to the left 4 units. So I'll take each of my points and go to the left 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so I'll shift that to the left 4 units, and so that's what we look like now. And notice if I shift my horizontal asymptote left, it stays put. All right, the next thing that we need to do is reflect this thing vertically over the x-axis. So I'm going to take my green one, and I'm going to reflect everything up and down across the x-axis. So I'm going to take everything that's positive and make it negative. So here, this first dot here is 3 units above, so it's going to reflect to 3 units below. This point here is 1 unit above, so it's going to reflect to 1 unit below. And then this little guy here is 1/3 units above, so it's going to reflect to 1/3 units below. And so when we reflect this thing up and down, try my best to make sure. There we go. Okay, we're going to look something like this after we reflect this thing up and down. And the last thing that I'm going to do is take this entire thing and I'm going to shift that purple one down 2 units. So I'm going to take each point and go down 2. 1, 2, 1, 2, 1, 2. And when I do that, and I connect these, notice that my horizontal asymptote also shifts down. There we go. 2 units with that graph. This slides down as well. And so I'm going to have a new horizontal asymptote at y equals -2. So this is all my scratch work. I'm going to write the final version over here. And so we had a horizontal asymptote at y equals -2. And my final graph was this guy. So I was at -3, -5. I was at -4, -3. And -5, -2 1/3. Okay. And so now I've got my points. I'll just connect them with a nice, smooth exponential graph. And there you have it, our final transformed exponential graph. All right, and that is transforming exponential graphs. So again, lean on your previous training from the graph transformations. You've got this. Let me know if you have any questions.